When we are using hypothesis testing for the mean, but we have small samples where we do not know the population standard deviation, then we have to use what we call the t-distribution. We've done this before, we just haven't done the hypothesis testing part. So most of this is review. We have to use the degrees of freedom. We still have left tail, right tail, and two tail. It just means that our distribution models have slightly thicker tails depending upon the degrees of freedom. So none of this is new so far. So if we're going to find the critical values for a t-distribution, you can't use your calculator unless you have an inverse t-distribution button. I do not have one, so we have to use the tables for those. So if I have a t-distribution where it is a left-tailed test, that means that it's shaded on the left. We have to find the t naught for this spot where alpha is equal to 0.05. So we have to find the degrees of freedom, which is going to be n minus 1, which is 21 minus 1, or 20. Using the table for t distributions and the alpha level of 0.05, we would get that t naught would be equal to negative 1.725. And then we would use that to compare with whatever we're testing to see if it's within that rejection region. So you have to get that from the table. And those tables are copied onto your note page for this whole chapter 7. If we have a critical value of a right-tailed test where alpha is 0.01 and n equals 17, so this time we're on the right tail, our degrees of freedom will be 16, and our alpha level, we can use 0.01, or we can do 1 minus 0.01, which is going to give us 0.99. Which gives us a t naught value of 2.583, which would be the number we would use to either decide to reject or not reject. And then finally, if we're doing a two-tailed test, we would have to find both negative t naught and positive t naught. So alpha is split between the right tail and the left tail, so this is 1/2 of alpha, and this is the other half of alpha, which is going to be 0.05. And our degrees of freedom will be 25, one less than our total of 26. So t naught from the tables, and you can use the right tail or the left tail, using 0.05 as your half of alpha, would give us plus or minus 1.708. So this is negative 1.708, and this is positive 1.708. So if you're doing a t-test using a t-distribution, when you have small samples where sigma is unknown, your steps are to follow these. Most of these are not new. You still have to check your conditions. Stating the null and alternate hypothesis is new to Chapter 7, and identifying that correct alpha level. Degrees of freedom is not new. You need to use the table in order to find your critical values. We found the t value before using this equation. And then this is new. We have to decide whether you're going to reject or fail to reject, and then make sure that you're interpreting your claim. Let's do an example together. A used car dealer says that the mean price of used cars sold in the last 12 months is at least $21,000. You suspect this claim is incorrect and find that a random sample of 14 used cars, it's random, check, sold in the last 12 months has a mean price of $19,189 with a sample standard deviation of 2950. Is there enough evidence to reject the dealer's claim using an alpha level of 0.05? Okay, so let's write down what we know. We need a null hypothesis and an alternate hypothesis. The dealer's claim is that he has the mean price that he has sold is at least $21,000. You're trying to reject that claim. So the mean price is greater than or equal to 21,000. That means the alternate would be that the mean price is less than $21,000. Our n is 14. Our sample standard deviation is 2950. We don't know sigma. We don't know the sigma is unknown. Our population standard deviation. And we know that our sample mean is 19,189. From that, we can find our degrees of freedom, which is going to be 14 minus 1, or 13. We know that using our alternate hypothesis, this is going to be a left-tailed test. Where our alpha is 0.05. So we need to find our T naught using an alpha level of 0.05 and a degrees of freedom of 13. Our T naught from the tables, our T naught is 1.771. We're going to find our standard error, which is going to be our sample standard deviation, 2950, divided by the square root of n, which is 14. So our standard error is going to be 788.420 6636. Now we're going to find our t value by taking our sample mean, which is 19189, minus our population mean, 21,000, divided by a standard error, which gives us a t-score of negative 2.296997128. Now, since this is a left-tailed test, this t-value will be negative here. So at this z naught, that's negative 1.771. And this is going to be well within that region. But even if we weren't sure, we could find our p-value, which will be TCDF of negative 200 to this z-score, negative 2.2969971128. And then we need our degrees of freedom in here, which is 13, in order to find that p-value. And the p-value is going to be 0.019437419. That's our p-value. And that confirms, since p is less than alpha, alpha is 0.05, that confirms that we would reject the null hypothesis. Which brings us to our conclusion. With a p-value of 0.0194, we reject the null hypothesis. There is enough evidence to claim, or to support our claim, that the mean price of cars sold in the last 12 months is less than $21,000.